Interestingly enough, it says we have the Warsaw Team talking about what they have done. And interestingly enough, one of the team is from University of College in London, and two people from University of Warsaw. So Marek Masniak, Patricia Krishna, and Marek Shiba will talk about their student participation in HPC. So let's take it from here.
Good evening, I'm Marek Skiba and I'm studying computer science at the University of Warsaw.
Good evening, I am Patricia Krzyna and I am also studying computer science at University of Warsaw.
Good evening, I'm Marek Masiak and I'm an incoming second year computer science student at the University College London. And we're gonna talk a bit about student participation in HPC amidst a global pandemic. So maybe to begin with, let's briefly discuss what are student cluster competitions and the rules. The competition has various difficulties, tasks that require a vastly different range of expertise. The two most significant types of expertise being hardware and cluster administration expertise and software expertise. Normally, the team would split into two sub-teams where one builds cluster from parts, installs the required software such as compilers, MPI, CUDA, etc., and benchmarks the cluster, while the second sub-team focuses on the competition tasks. Currently, however, the division tends to fade away due to the fact that these competitions are being held online. Building a cluster from parts is replaced with choosing the right cloud instance and setting it up from predefined template. As for the software part, the competition tasks include real scientific problems where the goal usually is to either obtain the shortest execution time or to run as many workloads as possible. Some problems include writing code from scratch, and some require optimizing already existing code. There are three major student cluster competitions throughout the year. Student cluster competition during the ISC conference in Frankfurt, Germany, which was very recently mentioned in the previous presentation. The ISC student cluster competition is this ISC student supercomputer challenge in China. Its location varies. And the student cluster competition during the SC supercomputing conference in the USA. Its location also varies as the conferences. Right, so this is a picture of our cluster from the SC19 student cluster competition. This was the last competition, which was held in real life. We had 5 nodes, 2 of which had NVIDIA V100 GPUs. It was assembled from hardware parts in the ICM center at Kupiecka Street in Warsaw, and later shipped from Poland to the USA. And to give you a sort of a sense of or a feel for what those, I believe there was a video here. Okay, never mind then. Maybe it's gonna be at the end of this presentation because we had a video to showcase what does the student cluster competition feel like. Oh no, there it is.
15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's done! All right. Well done, everybody.
Thank you very much. Yeah, so this was the very last, the very end of the student cluster competition during the C19 conference, which marked the end of a 48-hour non-stop student cluster competition. This is what the team looked like at the SC19 conference.
And this is how it looks like right now. This year, our team was made up remotely, and actually we never met in full composition in real life. It was definitely something new for all of us to solve problems together using only online communication, but we quickly adjusted to this environment. Let's talk about competition this year. The first one we took part in was Student Cluster Competition 2020, held in November. This event lasted 24 hours and we had 5 problems to solve during this time. Although applications were known before this period of time, exact tasks were unknown, so it wasn't easy to actually prepare for everything. Whole competition was held online, thus instead of creating our own cluster, we needed to use hardware provided by organizers. They decided on using Azure Cycle Cloud, and we got our first test credits about a month before the event. During the competition, we also had a limited supply of money, and it added an additional aspect of cost management. First task we needed to solve was benchmarking. Every year, there is the same set of benchmarks to run during the competition: HPL, HPCG, and IO 500. The goal is to achieve the best score in each of the benchmarks by selecting the most fitting hardware and to run them, and optimizing different hyperparameters. The Community Earth System model is a fully coupled global climate model that provides state-of-the-art computer simulations of Earth's past, present, and future climate states. Our goal was to achieve lowest execution time of the simulations provided by organizers, which includes optimization of input files reading, overall computations, and output files writing.
The next task was GROMACS. GROMACS is a well-known molecular dynamics simulation toolkit. It is ported to GPU and it takes great advantage of it. We had to perform 3 studies. Among those studies was a default scaling performance study for the charm force field.
The next task was reproducibility. And every year, one of the student cluster competition tasks is reproducibility challenge. Before the competition, teams receive some scientific paper in the high-performance computing domain, and instead of best execution time, teams are asked to reproduce results from this paper and write a report in scientific format. This year, our task was to reproduce scalability results of a new X-ray computed tomography algorithm. And the last task was mystery. Mystery is like in many student cluster competitions, there is something like mystery. It is a task which teams know nothing about until the day of the finals. And this means that teams can't do anything to prepare for it. So the task verifies participants' fluence in using clusters, along with the skill of learning new tools quickly.
As for overall results, Student Cluster Competition 2020 was won by Tsinghua University from China, and all the teams used over $61,000 out of $70,000 in total.
The next competition we took part in was ASC 2021. And ASC is the world's largest supercomputer hackathon, and this year it was very, very special because due to pandemics, the 2020 and 2021 were merged in one big hybrid event with teams from mainland China participating on-site and teams from other parts of the world participating remotely. There were also different scoreboards for these 2 categories, and the whole competition was divided into 2 stages: preliminary, which lasted a couple of weeks in winter, and finals, which took place in May and was very exhausting for us, as we had to work for a couple of days in Chinese time zone, which means from around 2 a.m. to midday. As for compute infrastructure, in this competition, each virtual team received the same time of computer cluster on AWS. There were 4 CPU nodes, 1 storage node, and 1 GPU node with 4 NVIDIA Tesla GPUs. Default job scheduler system was Slarm, which we also use in our local clusters, so it was really, really easy for us to use it.
On ASC, benchmarks were the same as on SC, but without IO 500. The main difference was the lack of possibility of choosing multiple instances, and thus it came down to just optimizing hyperparameters and small system fine-tuning. The next task was the language exam, definitely one of the most interesting tasks for us. Our goal was to fine-tune the BERT-based model for multiple choice classification. Organizers provided both a base model and a modified race dataset, real English language exams from China. A score was calculated by combining trained model accuracy and learning speed. Our team was able to win an Application Innovation Award here by getting one of the best scores for this task. Quest, a quantum exact simulation toolkit, is a high-performance simulator of universal quantum circuits. Our goal was to achieve lowest execution time on circuits provided by organizers during the competition. We made a really huge effort to add multiple GPU support to its code, but unfortunately inputs we received were definitely prepared for multiple CPUs, or over 100 GPUs we didn't have, so we couldn't outperform other teams in this task.
The next task was PRESTO, which stands for Pulsar Exploration and Search Toolkit. It was the core of our tasks. And pulsars are fast-spinning neutron stars that emit strong beams of radiation, like stellar lighthouses. And some pulsars are very stable cosmic clocks that could help to detect and study black holes in distant galaxies. We were given the code that searches for pulsars using PRESTO, and our task was to parallelize the code, optimizing the usage of multi-core CPU hardware. There was also one more task in this final stage of ISC, the mystery app, that turned out to be MPAS, Model for Prediction Across Scales. And we had to run a simulation using this tool, but unfortunately compilation of MPAS came out to be a very complex process, and none of the teams managed to achieve satisfying results in this task. So now I will say something about the results we achieved in this contest. We received a first prize award for qualifying to the final stage, and there we took second place among teams participating remotely. We also, for winning the language exam, we received an Application Innovation Award. And we had the best results in benchmarks, which was marked on Twitter.
Please excuse me again. Moreover, the Warsaw team participated in research projects. Here it is. The research projects resulted in publications. This is the latest one. It was published in the IEEE Transactions on Parallel and Distributed Systems Journal. And it was published. It's a report of the reproducibility challenge from the SC19 student cluster competition. Right, thank you very much for your attention. And here we would like to thank the Interdisciplinary Center for Mathematical and Computational Modeling of the University of Warsaw, Dr. Marek Michalewicz, Marcin Semeniuk, Michał Hermanowicz, Maciej Szpindler, and Łukasz Kondraciuk for their guidance, help, and support.
Okay, so from my side also congrats to the Warsaw team. It's always great to see young people get to do these kind of achievements. You know, we need to keep this industry going and get new blood in this industry. So with that, please show my last foil for today. It was my pleasure to be the session chair today. I would like to thank all the speakers, all the contributions that we saw during my session, and I'd like to invite you to come tomorrow and of course the next days to this conference. And perhaps I'm the last one to speak. If so, then I wish you a nice day and I hope to see you soon.